So our project is an alternative fuel for groundskeeping at Santa Barbara High. I'm Zach. This is Max. Just loading.
So basically, right now, we have gas-powered lawnmowers and other vehicles that are used for groundskeeping here at the high school. And internal combustion motors have very high emissions, and Zach and I's plan is to lower those considerably by converting all the motors to propane, as we did with our go-kart.
So as you can see on this picture, the outlined area in red is Santa Barbara High. It's the property. And you can see a lot of that area in there is grass. And that's all has to be maintained and mowed, and like bushes get trimmed and stuff like that. So they use a lot of gas when they're mowing the lawns or using the leaf blower or stuff like that. So we proposed that we convert to propane to not only lower the amount that the school might spend on gas, but also to reduce emissions as well.
So this is what most of our lawnmowers here on campus look like, and they're pretty old, so they don't have what newer lawnmowers and gas-powered engines have, which are used to lower emissions, so they're pretty nasty for the environment.
Okay, so this is kind of why we decided with propane. This could be kind of lengthy, so hang in there. This is from the U.S. Department of Energy, and it's why it's kind of the benefits of propane. So the first benefit of propane, you can see there is energy security. And so in 2014, the United States imported about 27% of its petroleum, and transportation consumed more than 70% of that. And a lot of the time when we're getting this oil, it's not from America, it's from foreign countries, and the supply cannot be sometimes as reliable as you'd like it to be. So by producing propane here in the United States, which we already have the infrastructure to do, we produce a lot of the world's propane. I don't have the exact number, but I know it's more than like half. We grant a lot of energy security for the United States. Like, we just make it a lot more reliable way of getting energy.
So right now, what it would cost to get a new propane lawnmower would be thousands of dollars, and even though propane is cheaper per gallon, it would take a long time for us to start saving money, which is a huge issue. So what we can actually do for a fraction of the price is convert the motors ourselves with our own conversion kits, and that would cut prices a lot.
And then another one of the benefits is the fuel economy and performance. So propane obviously costs less per gallon than gasoline, and has a comparable driving range. So you can go near the same amount that on one tank that you can on gas. And it also has a higher octane rating, 104 to 112 compared to 87 to 92 for gasoline. And that could be potentially more power. It also gives improved engine life because of some of the characteristics, its combustion characteristics. It's just it's cleaner for the engine. It doesn't gunk it up as much.
Compared with vehicles fueled by conventional diesel and gasoline, propane vehicles can produce lower amounts of some harmful air pollutants, which is one of the main reasons that we're doing this, to lower emissions.
Okay, so here's some of our data. Figure 1 shows the end-use emissions, which is when the user actually combusts the fuel, how much emissions is released. And that's some of the lowest out of all alternative fuels. The only one that is beat by is natural gas, and natural gas is just there's not as much infrastructure for it. It's harder to implement on a larger scale.
And in Figure 2, it shows that although there are some fuels that are that have less emissions, propane is better to have for us because it's more realistic to get and easier to convert to, unlike ethanol, which is hard to convert to and costs more per gallon.
So this is our proof of concept. So to truly test the viability of propane, we took a go-kart that previously ran on a 6.5 horsepower kind of made by Harbor Freight Tools motor, and we converted it to propane on specifically those kind of camping style 16-ounce propane bottles.
Which if we were to use on a larger motor, like the picture that we saw earlier of the lawnmower, we would use a bigger style propane tank because it would last longer. So we basically started with a Craigslist go-kart that we got and painted it green because this is green engineering. And yeah, at first we were just gonna drop a bigger motor on it, but that's not very green and it would just cost more to convert. So we decided to stick with the original motor and just convert to a propane engine. And we're producing about the same amount of power and it's much more efficient and the emissions are much cleaner for the environment.
And we want to kind of emphasize that this kit that's on that isn't available to buy. We kind of made it ourselves. We kind of winged it. It's something we seem to be good at. We modified the original carburetor, bought some fittings and the hose, and just enlisted the help of my dad to kind of fabricate some of the parts. Like he welded up that bottle mount that's on there, and a couple of the fittings required a little bit of fabrication work, which my dad is very good at, as it is his profession.
We could have purchased a conversion kit, but those cost over $100, and this was well under half that, and we did it ourselves.
And if anyone wants to see it run, we could try to demonstrate it here at the end. So these are our methods. And this is kind of what we've decided. These are not, very detailed, but they go into what the kind of steps of how we would want to accomplish this goal of converting the engines. So the first thing would be to locate all the small gas engines on campus that are convertible. Some of them are not, just based on their design, and ones that are on the bigger mowers. Sometimes they'll be electronically fuel injected, and then those are. It makes it not worth it to convert because of the high price for doing the conversion. So you have to research the parts that you need to convert each engine. Some require more than others.
Every engine is different and requires different parts.
Mm-hmm. So then we would want to apply for a grant, like the one from this competition, to cover the conversion. Then we would be purchasing the parts and begin slowly phasing out gasoline tools so that there's not, they're just without their tools for a long time. We just kind of work them in slowly. Then we would want to establish an infrastructure for keeping the tools fueled, either by getting a propane tank, maybe something along the lines of like a 20 or 30 gallon propane tank to be fueled every 2 weeks or so, or going through a fuel company like McCormick's, which sells propane in its liquid state that you can buy, and then create a write-up, kind of what this is on the whole process, and publish it, encouraging other schools and businesses to do the same. And this is our kind of way to determine when you get return on your investment. And this is the formula, kind of goes like this. So the 350 is derived from the price that we paid for our conversion. That's kind of an arbitrary number. It could change. But ours was right around $35. And this is for a hypothetical 10 engines, which is right around what we think would be used. So then that number is divided by the number of gallons of gas that we would use times the price. And $2.85 is the average price for gas in Santa Barbara as of like 2 days ago. And $1.77 was the cheapest I could find propane for sale from a primary producer. They sell them. There's like two different kinds of propane stations. A secondary, which would be like somewhere where like you get gas. They have just like a propane pump kind of. But primary like vendors kind of are more towards like the industrial side, and you have to like have a membership with them and stuff like that. But if we were going to be establishing this as a normal thing, that wouldn't be that hard to do. Then multiplied by 1.37, because that's the amount of, that's kind of a coefficient to describe how much propane you need to equal the same amount of BTUs as 1 gallon of gas. And then that's derived from, there's 125,000 BTUs in 1 gallon of gas and 91.5 thousand in 1 gallon of propane. And then that gives us 83 months or just less than 7 years until we would see return on our investment. And this formula could change. That's just kind of how it is right now. We're not sure if that number is 100% accurate, but that's a pretty good estimate.
Because gas prices could go up or down.
Yeah, gas prices could go up or down. The amount of the conversions could change depending on the engine, and the amount of propane could change. There's just a lot of, and the amount of actually gallons that they use, like depending on, you know, if they're mowing more one month or another. So that's just kind of like a kind of in the middle estimate. Okay, that's our presentation, and we'd like to move now into a question and answer / open forum. Any questions?
Can we see this thing running?
I think so, yeah.
Great. And then I have one more question. You said this is your prototype, right? Did you ever look into the other vehicles that are on campus or the other?
We never had enough time to really go and like get and break down some of it and look at what really it would take compared to this one, just because that they're using them actively and we don't really have access to a big lawnmower like that. If maybe, I don't know, sometime during the summer or something like that, we could get access to them when they're not mowing as often. That would be the way that we could actually kind of take a look at the internals of that engine compared to this one and see how difficult it would be to convert.
Right on.
Most of the motors are Honda or Briggs & Stratton, which is basically what this motor is. It's like a knockoff of that. So it wouldn't require many different tools than this. But
You would just need bigger fittings and bigger hoses just for kind of the higher loads that would be on the bigger engine.
yeah.
It's the same basic principle though. So yeah, we can try to run it. Hopefully there's
Running here
propane
is
in
pretty
there.
loud.
Yeah, we'll take it outside because it's very loud.
Very dangerous?
No, it's not dangerous, it's just loud.
That's the mission to the gas.
Then we gotta go after the
Efficiency, boys.